In this video, we have a definite and indefinite integral to evaluate. Now, the definite integral, we could break it up into two integrals, 1 over x. That's easy to evaluate. That's the natural log of absolute x. And then we'd have minus ln of x over x. We could use that U-substitution there to evaluate it. And that'll work. What I'm going to do is I'm going to let u equal to what's in the numerator. So then du will equal to the derivative of 1 is 0, the derivative of ln of x is 1 over x, and of course you have the minus, and we got the dx here. So this will be your u in the numerator, and notice I have a dx over x, and over here dx over x. It's the same thing, 1 over x times dx would be dx over x. So I could just go ahead and multiply both sides of this one by negative. So that'll tell me that 1 over x dx, which is this part right here, is equal to minus du. So I could set this up this way. Say this is the integral. That's my u. And then dx over x, that's minus du. So I'll put the minus out in front, du. And I could change the limits of integration, so I could just do the integration here and then go with the original ones. So notice if I let, this is in terms of x here, the lower limit is x equal to 1, but I want it in terms of u. So put a 1 here where the x is. Natural log of 1 is 0. So I got 1 minus 0, so u is equal to 0, or 1 I should say. And then at the upper limit, the x is equal to e. So plug in an e there. Natural log of e is 1. So 1 minus 1 is 0. So in this case, u equal to 0. So the limits then will go, the lower limit will be 1, upper limit will be 0. And then we integrate. Basic integration here, u. And then integrate with respect to u, du here. So this will be a u squared. Add 1 to the x one and divide. I get u squared at the minus there. And then the limits of integration go from 1 to 0. And then we evaluate at the upper limit. So plug in a 0 there where the u is. That's going to give you 0, and a minus will still be 0. And then it's a minus. Now we plug in 1. So 1 squared is 1 over 2 is a half, and then you have the minus there. So it's minus 1/2 here. And then we're subtracting, so minus double negative there makes it a plus 1/2, and 0 is equal to 1/2. And that's the answer there. And of course, like I said, you could break it up into two integrals. 1 over x minus ln of x over x, and either change or leave the limits the way they are, depending on what variable you're using, and it'll work. Now for the next one, this is your indefinite integral. So we could just go ahead and divide through. So let's divide through by cosine. This will be 1 over cosine. That can be written as secant. 1 over cosine of x, secant, and cosine of reciprocals. So it'll be secant of x. And then divide through, again, the sine by cosine. You got sine over cosine. That's tangent of x. Basic trig identity. And then you do the integration. Now you're pretty much expected to know the value of these integrals, but you can derive them. Remember, tangent of x is sine over cosine. So you could use a u substitution there, let u equal to cosine, and you'll get the answer that I'm going to give you right now. Secant of x is one that I derived in one of the videos that I've done, but it's one that, again, you need to know. Most instructors will expect you to know the integrals, the evaluations of each of these integrals. So for the secant of x, that's going to be the natural log of absolute secant of x plus tangent of x. These are absolute values here. And again, the formula for the integral of tangent of x is minus natural log of absolute cosine of x. And then you have a constant of integration. Now sometimes you may see this in some of the formulas that you're given in the textbook. You might see this as integral of tangent of x is equal to, instead of a minus here, it's a plus natural log of absolute secant. Just in the way to write it, because if you take this minus here and put it as an exponent to the -1, this becomes 1 over cosine, but 1 over cosine is secant. So you might see it this way. You might see it with a plus here. Instead of cosine here, it'll be secant. But this is the integral for this particular one. Again, this one has a constant of integration because it's an indefinite. Over here we have a definite integral. Thanks for watching. We'll see you next time.